So far in chapter 4, we have looked at a couple different distributions. We looked at a general probability distribution, we looked at binomial distributions, and now we have two more, geometric and Poisson. First, we're going to look at geometric. So the way that we're going to know which distribution to use, there are key words in the problem, and I'm going to show you those as we go along. So with the geometric distribution, the trial is repeated until a success occurs. So let's say we are making phone calls. The first time we have a sale, that's when we'll stop the trial. So we'll keep calling until we have a sale. If we're looking at, let's say, a quarterback throwing the pass, the first time that it's caught is when we'll stop the trial. So these repeated trials are independent of each other, like throwing a football. If the first one is not caught, that has nothing to do with the second one being caught. Same thing with phone calls and sales. The probability of success has to be the same for each trial. That's true. That's been true with the binomial as well. And then we're going to have a random variable x that's going to tell us what we're looking for when we want that first success to happen. Now, we are not going to be using these formulas because we're going to let StatCrunch do the work. With a geometric distribution, we're going to be looking for that word first. So this problem says that a study found that the smartphones made by a certain manufacturer had a failure rate of 43%. Now I know it says failure rate, but that's actually going to be our success, because for us, a success is that the phone doesn't work anymore. I know that it seems kind of backwards, but that's what we're looking for in this experiment. 4 smartphones made by this manufacturer are selected at random. Find the probability that the 4th smartphone is the first one to have a failure. So that word first, that's what we're looking for. As soon as we see that word first, we know that we have a geometric distribution. So we want the probability that the first failure, or the first, for us, that's a success, is the 4th phone. So we don't want the first 3 phones to fail, but that 4th one is going to fail. So we're going to go into StatCrunch. We're going to use stat calculator geometric. We're going to put in our p of 0.43. We're going to put in that we want the probability of x equal to 4. And you hit compute, and you're going to get your probability right here. And so it's about 0.08. And that's the probability that the first phone to fail is going to be the 4th phone. This just shows you for that problem what we're going to do. So we're going to go to Stat, Calculator, Geometric. We're going to use number of trials. We're always going to use that for this class. At that point, this next screen will pop up. We'll put in our p-value. We're going to put in equal 4 and get the probability back out. All right, so this one's the same idea. Let's see, this is a second manufacturer, and they had a failure rate of only 14%. So that means that our p is 0.14. 6 smartphones made by this manufacturer are selected at random. Find the probability that the 6th smartphone is the first one to have a failure. Again, that word first tells us that we're going to use a geometric distribution. So we're going to go into StatCrunch. We're going to do stat, calculators, geometric, and number of trials. Whoop. We're going to put in the p-value of 0.14. We're going to put equal 6 this time because we want the probability that the 6th smartphone is the first one to fail. And when we hit compute, we get our probability on this side. So our probability is 0.066 that the first failure that we're going to see is phone number 6. Okay, the last distribution we're going to look at is the Poisson distribution. The way we're going to know that we're in the Poisson distribution is they're going to give you the mean. So the mean is given. You still have the probability of the event occurring is the same for each interval. And we are going to look at the number of occurrences. So we will have an x. So this time, instead of having a p, we're going to have the mean. So we're going to have mu. But we're still going to use StatCrunch, the same idea, but we're going to use calculator Poisson this time. So we're not going to worry about the formula because we are going to use StatCrunch. All right, so this problem says the mean number of accidents per month at a certain intersection is 3. Sometimes it says is about. That's okay too. So they literally gave me the mean. That tells me that I'm in a Poisson distribution. It says, what is the probability that in any given month 4 accidents will occur at this intersection? So we want the probability that x is equal to 4. We've been given our mean. So we're going to go into StatCrunch. We're going to go to Stat, Calculators, Poisson. I know it looks like poison, but it's Poisson. And then we're going to put in what we know. So we're going to put in the mean of 3. We're going to put in the probability that x equals 4. And then we will get our probability once we hit compute. So in this case, it's going to be 0.168. That's the probability for this data that we'll have 4 accidents in any given month. So this is showing you again, we're going to go to Stat, Calculator. I don't know why this other stuff is clicked. We're going to come down to Poisson. We're not doing that one. And then we put the mean in, we put that x is equal to 4, and we get our probability. Thank you, StatCrunch. This is the same problem, but this time they want to know the probability that more than 4 accidents will occur. So this is why we practiced all of that inequalities and translating sentences so that we can be really careful about whether we need greater than or equal to, less than or equal to, or equal to. So this says more than 4. That means that we want the probability of x greater than 4. And so inside StatCrunch, we're still going to go into Stat, Calculators, Poisson. The mean is still 3, but we're going to put greater than 4 here. And notice on the graph, that also shows, I don't think I showed you that for the binomial distribution, but you can see that it's red for 4 or greater. So that's a good double check as you're going through this work. And then we get our probability of 0.185. Okay, so here's a quick review. For a binomial distribution, we're looking for the words randomly select, and we don't want to be given the mean. We don't want to see that word first. So I usually work my way from the bottom up, from Poisson up. So I look to see if they give me the mean, because if they give me the mean, I know that I'm in a Poisson distribution. Then I look for the word first. If I see the word first, I know I'm in geometric. If I don't see either of those, but I see randomly select, then I know I'm in a binomial distribution. We're going to use StatCrunch, but if they ask for the mean, variance, and standard deviation, we do have to use these formulas, the n times p, n times p times q, and then the square root of n times p times q. So that is for the binomial distribution. All right, so let's write. We're going to use StatCrunch, so we'll use Stat, Calculator, Binomial. That's for the probability. For the mean, we're going to go ahead and just use our Casio for the mean, variance, and standard deviation. All right, if you see the word first, now your resource sheet also has these keywords in it and tells you how to get into StatCrunch. So if we see that they give us P, they give us the probability of success, but then the wording is that we want to see the first success, Then we know we have a geometric distribution. And so we're going to use StatCrunch again. We're going to use stat calculators, geometric number of trials. We're going to put in P, and then we're going to put in the probability of X equal to or X less than whatever the problem asks us for. Okay, then finally we have Poisson. If we see that the mean is something, so it's given, or the mean is about, that's okay. The point is that they give it to you. Then we have a Poisson distribution. So we're going to go into stat, calculators, Poisson. We are going to give the mean and then fill in the probability of however they're asking for it. Okay, so the trick is figuring out which one it is. And it's even saying, find the indicated probabilities using the geometric distribution, the Poisson distribution, or the binomial distribution. So this one says, assume the probability that you will make a sale on any given telephone call is 0.25. Okay, so I know that that's P, 0.25. Find the probability that you make your first sale on the 5th call. All right, so as soon as I see that word first, I know that I have a geometric. So I know that I'm going to go to stat, calculators, geometric, number of trials. So the first one wants us to make the first sale on the 5th call. So that's over here. I'm going to put the P of 0.25 in. I'm going to put equal 5 because it said make your first sale on the 5th call. And that's going to give me the probability back out. Okay, then it says make your sale on the 1st, 2nd, or 3rd call. So there's a couple different ways. You can do them one by one. That's what I did here. I did X equal 1, X equal 2, X equal 3. Or you can do the probability of X less than or equal to 3. That's going to give you the same answer. So either way. And then, so that was make your sale on the 1st, 2nd, or 3rd call. So that gave me 0.578. Now the last one, you again can do two different ways. We can use what we know about probabilities, that all the probabilities have to sum to 1. And so we could, because it says do not make a sale on the first 3, we can do 1 minus the probability of making a sale on the first 3, right? Because that's what we did on that first one, was make your sale on one of the 3. So we could take 1 minus 0.578 that we found for B and get 0, we need another 2 on there, 0.422. The other thing you could do is the probability of X greater than 4. That would work as well. All right, again, they're asking us to find first whether this is geometric, Poisson, or binomial. The problem is a newspaper finds that the mean number of typographical errors per page is 5. Okay, so I see that mean is, that means that I have a Poisson. Find the probability that exactly 4 typographical errors are found on a page. So that means I'm going to go to StatCrunch, stat calculators, Poisson. I'm going to put in that the probability is, we want to know the probability of X equal to 4 because it says exactly 4. I'm going to put in our mean of 5 that they gave us, and that gives us 0.1755. For the next one, it says at most 4 typographical errors are found on a page. So that's going to be less than or equal to 4. We still have our mean of 5. At most means less than or equal to, and then again, StatCrunch gives us the probability of having at most 4 typographical errors on the page. And then lastly, we have more than 4 typographical errors. So on this one, we have x greater than 4, but we still have our mean of 5, and it gives us the 0.5595. Now notice, if I add these two together, I get 1. That's what we know about probabilities. If you have every single case in there, the probabilities need to sum to 1. So if I have less than or equal to 4, and then I have greater than 4, those two need to sum to 1. All right, one more. Again, we're looking for whether this problem is geometric, Poisson, or binomial. I see 59% of US adults oppose hydraulic fracturing or fracking as a means of increasing the production of natural gas and oil in the United States. Okay, so that tells me that P is equal to 0.59. You randomly select 5 US adults, so that means that N is equal to 5. Find the probability that the number of US adults who oppose fracking as a means of increasing the production of natural gas and oil in the United States is exactly 2. Okay, so they did use that word means, but they didn't give you the mean. They were using it as a verb, not as a noun. So I always look to see if they give me the mean. Like, I look at that first. If they gave me the mean, I would know that it was Poisson. Then I look for the word first. The word first is nowhere on here. Therefore, it's not geometric. And then finally, for binomial, I need to see that it says randomly select, which it is. It says you randomly select 5 US adults. So that tells me that this is a binomial distribution. I'm going to go into StatCrunch and go to Stat Calculators Binomial. I'm going to put in N. N is 5. P is 0.59. For the first, for A, it's that probability that X equals 2. Hit compute, and you get 0.240 is the probability for this data that X is equal to 2. In other words, that 2 adults oppose the fracking. For B, they asked less than 4. So that would be P of X less than 4 with the less than sign, not less than equal, because it says less than 4. Again, all the same data goes in. Make sure you have a less than sign here. And we see that the probability of less than 4 adults opposing fracking would be 0.680. And then finally, the last one, they said at least 3. So that would be X greater than or equal to 3. We're allowed to include 3. So again, make sure StatCrunch has the greater than or equal to in the 3. And you see that the probability that at least 3 of the adults out of the 5 oppose fracking would be 0.665.